One.
Okay, right back where we left off. Let's see if I can confuse myself and others some more. See if I think I screwed my screen up here. Am I in the screen? Hello, make it bigger. Okay, there we go. So, right here, I was confusing us with this prop of alive. Um, we just check the truth value cell, and then we push each row. Okay, here we go. So we make a row array, and we push into output each row as an actual uh, table row, because our whole thing is really an HTML table. So yeah, for each, basically this whole thing just makes a row based on our 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 state that we set originally of 50 rows, and then that's going to give us a big array um, of these cell components. Let's see, the toggle length method is for the on click. Um, so basically, since we've used our grid system here to set up the ID, you'll see that later. Where is that? So actually, this would be a good point to go up to show you how what the cell component looks like. Well, here's our cell. So basically, this is like a blueprint for what each cell should look like. We're making 2,500 or however many, because I have a button in there that'll change. It'll actually change the amount of rows and columns. But this is our blueprint for our cell essentially, and it's just a TD, which is like a table data piece. Um, and so it's going to take this dot props that row colon this dot props that column for an ID. So each one is going to be identified by its place. It's going to have its ID be its place on the grid. And here's the conditionally render piece that I was telling about. For class name, you can actually put in a function here, or a ternary really, and based on the prop alive that we pass to it, if it's true, we give it the class alive and the class cell, and if it's false, we give it the class dead. So right there, that's how we can control the color of the cell that's rendered. Pretty simple system. And this ID setup comes into play here, where we split the ID in real quick on the colon. So XY is actually an array of the coordinates, and our new board equals this state of board, and new board first position, new board second position equals not new board first position, second position. So it toggles. Essentially, we make a copy of the board as it is, and then for the cell, we're actually looking up the cell, because we've got that information from the click event from the target. We've got the ID from the target, and we've split it. And we're just saying we're evaluating it. If it's true, we're going to make it equal false. If it's false, we're going to make it equal true. And then we just reset the state to new board. So when you click on a cell, it's going to change. And React is smart enough, it doesn't need to re-render the whole thing. It just knows, like, okay, well, just that one thing is changing. So we'll just re-render that one thing. This whole big function is going to check. Basically, you feed it the whole entire grid, and it takes that whole entire grid and it looks at the neighbors. And it had to include ternaries for above, below, previous, and next, because it could be a cell on the edge of the board, and the cell on the edge of the board, when it still needs its 8 neighbors, it's actually going to check the other side of the board, considered its neighbor. That gives your whole board an infinite structure. And all these things they work on counters. So the magic number is the amount of neighbors. And then based on that magic number, this is where we apply the rules of Game of Life. So if the magic number is 2 or 3, it's going to be true. And if the cell's dead and the magic number is 3, it's going to be true. Otherwise, you're dying. And so this basically just, up here, it's a map of the grid and then a map of the row. So it's just mapping. It's basically looking at every single value of your grid, and it's going to return a new value for each value based on the rules, based on the true false. And then when that changes, that's going to trigger an automatic re-render of the cell component. And then it's going to apply that rule alive and dead for the class name. And that's how it works. All that's left to add is the timer, which is the evolve method, which sets the evolution state to +1 every time it's called. And it calls that God function that we looked at above, whatever the state of the board is every time it's called. And so when we hit the start button, we make a timer with a set interval where we call that evolve function based on this, that speed times 100 milliseconds. So when speed is 1, the fastest the board, so the fastest it's going to go is 1/10 of a second. 100 milliseconds is the fastest you're going to, unless you come in here and change the settings. And then if you set it it's on a slider from 1 to 10. So, oh no, we've got it over here. So that's that life factor. This is going to change when we slide this. This is going to change. Excuse me, it's the speed factor. That's going to change that state, that speed. This is that state, that number. Stop button just clears that timer. The clear button clears the timer, but it makes a new board. And actually, it just maps false to every single value of the board. And then sets the state to the blank board and resets evolution. Reset stops the timer and calls the whole entire thing over again, just like on page load. Change speed. It just looks at the slider and changes the state of that speed, which affects the whole entire function. For some reason, I have console logs in there. Running out of time on this one again. We'll leave off right here. Yeah, well, this is a good spot to leave off. We'll leave off right here for next video.